Right, just going to make a quick video to help understand task 8. So in this video, we are looking at, or in this task, sorry, we're looking at a form of molecular homology. So we're looking at a comparison between 6 species to see how alike they are. And instead of using just their structural characteristics, by what we see in those species, we have some information about this molecule that they have in common. And this is RNA polymerase, or an RNA polymerase that is found across all of the species. And it has a section of it that varies in its amino acid sequence. And so we can use that part of RNA polymerase to see how many mutations have accumulated over time between these species, and that gives us an understanding then of how long they've been diverged from one another. So, quick revision. Do you remember what RNA polymerase is and where we have spoken about it? Have a quick think for yourself. It is that enzyme that is pivotal to gene expression in the nucleus, and it's responsible for the production of RNA, which would eventually become mRNA in the nucleus in the process of transcription. So, being a really important enzyme in gene expression, it makes sense that all of these organisms would have that enzyme or version of that enzyme that functions in their nucleus. So, what you're given is the sequences of this part of RNA polymerase, and doing a comparison means looking at each sequence and comparing it back to usually the top one, just to see what is different. And so I've gone through and I've highlighted all of the amino acids that are different from the mouse in order to compare it to the mouse. You're then asked underneath to calculate the percentage of amino acids in common with the mouse. And so if we just, the most, the easiest one to do then would be the chimp, because when we've gone through those sequences and tried to find a difference, there's actually no difference at all. It's probably important to remember that we're only looking at a small section of this enzyme. We're only looking at 60 amino acids, and really there'd be hundreds of amino acids that make up this enzyme. It might say up in the information. There we go. It actually is in the thousands. So we are only looking at a small section of that enzyme. But this section, anyway, between a mouse and a chimpanzee, is 100% the same. So we would call that 100% in common. The fruit fly, though, when we count these up, there's 9 differences, which means that there would be 51 so the fruit fly would have 51 amino acids out of 60 in common with the mouse, and times 100, and that would give us 85% similarity. So you have to go through and work out all of these based on how many amino acids they have in common, and get all of those percentages. Using that information, then, you're asked to construct a phylogenetic tree for these species. I find it easiest with a phylogenetic tree to start with the most similar and then work my way out. So the most recently diverged species out of these 6 would be the mouse and the chimp, because they are the most, they have the most in common. So if we start with that little clade, and then I can work my way backwards. And so the next closest, just by looking without doing the math and just by looking at the highlighting that I've done on that diagram, the next closest in similarity would be the fruit fly. And so on my phylogenetic tree, can pop in another branch and put the fruit fly down here because that one would have diverged earlier than the mouse and the chimp. And you are just working your way out, so the next most closely related, and so on. Until you've finished with all your species, and you can give your phylogenetic tree an ancestral root. And that is it. That's all you're looking for. Good luck.